Scientific notation. So in chemistry, we often use numbers that are very large. For example, if we're looking at number of atoms, before we even have a gram of water, we have to have billions and billions and trillions of water molecules to even see something. We also use numbers that are really small. So, for example, the wavelength of red light is measured in nanometers. So, this is a very small distance. So, we use scientific notation to save us the trouble of writing out all of those zeros, which we can easily lose count of. So, a really important number in chemistry is 6.02 times 10 to the 23rd. These are the number of things in 1 mole. And mole is just a way that we count number of atoms. Kind of like how you count eggs by the dozen, we count atoms by the mole. So if I were to write this number, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So if I were to write this number out, I would need to write this whole thing every time that I go to use this number. So to write a number in scientific notation, you're going to move the decimal until there is only one number in front of it. So one non-zero number. You're going to count how many spaces you moved the decimal. So this will be the exponent. A big number has a positive exponent, while a small number is going to have a negative exponent. And when I say small, I mean less than 1. So to finish up here, we want to write out the decimal and then write times 10 and write the exponent as a superscript. So for example, my first one here is 6,300,000. So there's a decimal place there at the end. I want to move that 6 spaces until there's only one number in front of that. So that would be 6.3 times 10, and since I moved it 6 places, I would put a 6 there. Here's another big number. So I'm going to move the decimal over 4 places. So this would be 9.47 times 10 to the 4. Okay, let's look at a couple of small number examples. So here, I'm going to move this decimal place over 6 spaces. So this would be 8 times 10 to the 6. Negative 6 here. So because we moved the decimal, because this is a number less than 1, we have negative 6 as our exponent. Then here, 1, 2, 3. Again, we only want one number in front of the decimal. So this is going to be 7.36 times 10 to the negative 3. Now, what if you had a number like this? Like, let's say that you have a number that you measured. 1. And let's say that in this number, the estimated place when we took this measurement was the tens place here. So I'm trying to write this number in a way that lets me know that I measured out to that place. So I would write 1.320 times 10 to the 1, 2, 3, 4. So that's how you would handle that situation. So go ahead and pause the video and take some time to practice going in each direction with scientific notation. When you're ready, you can return here and check your answers. Okay, so here are the answers for each of these. So take a moment here and check your work. The error that students usually make is in counting the number of places that you move over. And remember that you only want one number in front of the decimal. So if you want to add 3 zeros to a number, such as going from 1,000 to 1,000,000, how many powers of 10 are required? So the difference between these two numbers is a factor of 1,000. So that's 3 powers of 10. What makes a billionth different from a billion, or a hundredth different from 100? How does this relate to the plus or minus sign? So 100th is 1 out of 100, which is a decimal, a fraction, whereas 100 is a whole number. So the sign of the exponent indicates if this is a big number or a small number. So if it were 100th, we would use a negative, and for 100, we would use a positive. When you write out 10 to the second or 10 to the third, do you write the zeros before or after the 1? So positive exponent means it's a big number, and the zeros come after the 1. And if you write out 10 to the minus 2 or 10 to the minus 3, do you write the zeros before or after? So negative exponents mean that we have a small number. So those zeros are going to need to go before the 1.